Today we're on pages 178 and 179 of our textbook. Lesson 4, Factoring Completely. Factoring can produce more than just two factors. In exercise number 1, we will first warm up by multiplying three factors together. Write each of these in their simplest form. The second question should take little time to do. 1a, we have 2 times x plus 4 times x plus 7. Multiplication is associative, so we can multiply the two binomials first if we like, get a result, and then multiply the result by 2. Or I can multiply 2 times the binomial x plus 4 and get 2x plus 8. And then multiply x plus 7. So the double distribution here, 2x times x is going to be 2x squared. 2x times 7 is a positive 14x. 8 times x is 8x, and 8 times 7 is 56. Combining like terms, 14x and 8x is 22x. This is our result. For b, we have 4x times 3x minus 2 times 3x plus 2. Well, notice the binomials here are conjugate pairs. So if we were to multiply these, in fact that's what I'll do first, is multiply the two binomials, which are conjugate pairs. The result is going to be the product of the first term, so 3x times 3x, or 9x squared, minus the 2 squared. Bring down the 4x, and now distribute 4x. That's 36x to the third minus 16x. So now we're practicing factoring completely. To factor completely means you have factored until you can factor no more. Always when we're factoring, you always look for greatest common factor first. So factoring completely, there's a GCF here to these three terms. It is 2. Taking out 2, we get x squared plus 11x plus 18. Now the trinomial inside parentheses, the leading coefficient is 1. We go to the constant 18. Are there factors of 18 that add to 11? Yes, 2 and 9. So this factors into the binomial x plus 2 and x plus 9, and bring down the 2. Can the binomials be factored further? No. So this is factored completely. B, looking at these three terms, there's 5x, that's a GCF. Factoring out 5x, we get x squared minus 2x minus 8. Trinomial, the leading coefficient is 1. Factors of negative 8 that sum to negative 2 or negative 4 and 2. This factors into x minus 4 times x plus 2, and bring down the GCF 5x. See, there's a GCF 2. Factor out 2. We get x squared minus 25. This is just two terms. It is difference of perfect squares. And this factors into x plus 5 times x minus 5. Bring down the 2. D, what's common to those two terms is (2x), 9x squared minus 49. And the binomial here is the difference of perfect squares. It factors into 3x plus 7 and 3x minus 7. And bring down our GCF. E, common to the three terms, is 2x, x squared plus 8x minus 105. Looking at the trinomial, the leading coefficient is 1, so we go right to the constant. The factors of negative 105 that sum to 8, negative 7 and 15. And if ever you run into a situation where you're not sure of the factors, go to the calculator, and we can simply take negative 105 divided by x and look at the table of values. Right, so these are factors of negative 105. 1 times negative 105, 3 times negative 35, 5 times negative 21, and 7 times negative 15. That's going to sum to a negative 8. We want a positive 8, so just switch those signs. Okay, so we have x minus 7 times x plus 15, and the GCF 2x. And this does not factor further. F, common to the three terms, is x squared. X squared plus 8x minus 20. Leading coefficient is 1. Factors of negative 20 that sum to 8. 10 and negative 2. Okay, so far, once we've factored out a GCF, we've had either a trinomial where the leading coefficient is 1, so we went right to the constant and found those factors of the constant that sum to the coefficient of the linear term, or we ended up with a binomial, which was a difference of perfect squares. Now, continuing with G, the GCF greatest common factor here is 2. Factor out 2, we have 3x squared plus 13x plus 10. The trinomial inside parentheses, the leading coefficient is not 1, it's greater than 1, it's a 3. So this is where we're going to do our rainbow, right? We multiply 3 times the constant, 10 is 30. And now the factors of 30 that sum to 13 are 3 and 10. Because we had to do our rainbow and multiply, this is where we rewrite our trinomial into 4 terms. We're simply taking the 13x and rewriting it as 3x plus 10x. Bring down the constant plus 10. And now we split. This is grouping 4 terms. So we split GCF, copy down the operator. GCF to the first 2 terms is 3x, x plus 1 in parentheses, and the GCF to the second 2 terms is 10. So x plus 1 is 1 factor. 3x plus 10 is the second factor. And let's not to forget to bring down our original GCF of 2. So this is factored completely. H, what's common to these 3 terms is 5x. 2x squared minus 5x minus 7. In parentheses, the trinomial, the leading coefficient is greater than 1. So we want to multiply the leading coefficient times the constant. 2 times negative 7 is negative 14. The factors of negative 14 that sum to negative 5 are actually negative 7 and 2. We are rewriting negative 5x as negative 7x plus 2x. Split. GCF x, 2x minus 7. GCF here is 1, 2x minus 7. 2x minus 7 is one factor, x plus 1, the second factor, and 5x. Let's not forget to bring that down. Okay, so this is factored completely. I take out the GCF, which looks to be 4. 3u squared minus 7u minus 6. The trinomial leading coefficient is greater than 1, so we're going to multiply. 3 times negative 6 is negative 18. The factors of negative 18 that sum to negative 7 are negative 9 and positive 2. So we are rewriting negative 7u as negative 9u plus 2u. And 4 terms we're grouping, split the first two, GCF 3, u. And the second 2 terms, 2 is common. U minus 3 is one factor, 3u plus 2 the second factor, and the GCF of 4 comes down as the third factor. Again, you're more than welcome to pause the video and go ahead and work on your own if you like. But continuing on to the next page, here we have 3 terms, the GCF being x to the third. Okay, now we have here an x to the fourth. This would be considered a quartic trinomial, right? So just like we've been factoring our quadratic trinomials, quadratic meaning the highest degree or the highest exponent is 2, we can do the same here. Okay, just think of the leading coefficient is 1, the factors of negative 4 that sum to negative 3 are negative 4 and 1. So we would have x minus 4 times x plus 1. Bring down the x cubed, right? But this isn't quite right, because x times x here would give us x squared. We need x to the fourth. So make each of these x's x squared. Now, you have to recognize that x squared minus 4 is the difference of perfect squares, so that needs to factor further. Factors into x plus 2 times x minus 2. Bring down the x cubed, and x squared plus 1 does not factor. So this is our final factorization, or a complete factorization. Okay. GCF looks to be x squared, 15x squared plus 2x minus 1. The trinomial, the leading coefficient is greater than 1, it's 15, so we do our rainbow. 15 times negative 1 is negative 15. The factors of negative 15 that sum to 2 are 5 and negative 3. So rewriting the trinomial, 4 terms, 15x squared plus 5x minus 3x minus 1, split, copy down the operator. GCF of the first 2 terms is 5x, 3x plus 1, and common here is 1, but you're actually taking out a negative 1, so 3x plus 1. 3x plus 1 is one factor, 5x minus 1 a second, and our GCF of x squared needs to come down. Just check, can any of these be factored further? No. This is our complete factorization. What's common to these three terms? 3x. 4x squared plus 12x plus 9. Leading coefficients greater than 1, so we multiply. 4 times 9 is 36. Factors of 36 that sum to 12 are 6 and 6. Rewriting 12x as 6x plus 6x. Now let's split. Okay, so we have 2x plus 3 in parentheses, and then we have 2x plus 3 outside, and our GCF 3x. And this is our complete factorization. Just keep in mind that this can be also written as 3x times 2x plus 3 squared. Anything common to all three terms? No. It's a trinomial. The leading coefficient is greater than 1, so we multiply the leading coefficient times the constant 6. We get 12. The factors of 12 that sum to negative 13, negative 12, and negative 1. So grouping. Splitting the first two terms. GCF 6x. The last two, what's common is 1, but you're taking out a negative 1 actually. Ooh, this is a good mistake. 6 times 6 is 36. So let's go back and correct this. I see that, well, something's not working here. I have to take out 1, I get an x, negative 1, I get x minus 6. And now what's in parentheses doesn't match. So I have an error here. But caught the mistake. Let's correct it. 6 times 6 is 36. Factors of 36 that sum to negative 13. Negative 9 and 4. 6x squared minus 9x minus 4x plus 6. Split, bring down the operator. What's common here is 3x. 2x minus 3 in parentheses. Common to these two terms is 2, where you're taking out a negative 2. So 2x minus 3. So 2x minus 3 is one factor, and 3x minus 2 is the other factor. GCF 2x, x cubed minus 64. Difference of perfect cubes. Right, this is x cubed minus 4 cubed. So this is going to factor into a binomial and a trinomial. Remember, the signs go same, opposite, always plus. Binomial is x minus 4. Trinomial, the first term is x squared. The last term is 4 squared, which is 16. And the middle term is the product x times 4, which is 4x. Bring down the GCF of 2x. And this is factored completely. When you have the sum or difference of perfect cubes and you factor it, the trinomial result is not going to be factorable. So you don't have to say, oh, are there factors of 16 that sum to 4? Okay, here we have 4 terms. There's no GCF to all 4, so let's split, use our grouping. What's common to the first 2 terms is A, and we have A plus 3B. And what's common to the last 2 terms is 2, A plus 3B. So A plus 3B is our one factor, and A plus 2 our second factor. What's common to 24x to the 5th plus 3x squared? Looks like 3x squared is a GCF. You get 8x cubed plus 1. This is the sum of cubes. It's the sum of 2 cubes we have here. 8x cubed is 2x cubed, and 1 is 1 cubed. Okay, so the sum of the 2 cubes is going to factor into a binomial and a trinomial. The binomial are signs for same, opposite, always plus. Our binomial is 2x plus 1. Our trinomial, the first term is going to be 2x times 2x, which is 4x squared. The last term is going to be 1 times 1, which is 1. And the middle term is the product 2x times 1, which is 2x. Bring down the GCF 3x squared. And Q, we have 4 terms, no GCF to all 4, so we split. What's common to the first 2 is x squared, 3x plus 2. What's common to the last 2 is 4. We're actually taking out a negative 4 though. We get 3x plus 2. So 3x plus 2 is one factor. X squared minus 4 is the other factor. We are not done. X squared minus 4 is the difference of perfect squares, or difference of 2 squares. So that factors further into x plus 2 times x minus 2. And let's bring down our 3x plus 2. And here we have our complete factorization. Thank you very much for your attention.